In this example, we're asked to solve the equation 3 times 4 to the x equals 7. So we know this is an exponential equation because the variable appears up in the exponent. And if we want to solve, we've got to remove that variable from the exponent. Now, as it's written, we have a 3 being multiplied by the exponential term here. So remember that this is not equivalent to 3 times 4, 12 to the x. Remember, our order of operations says that x applies only to the 4, and then that whole thing is multiplied by 3. So if we want to use logarithms to rewrite this without the exponent, we're going to have to first get that 3 off of there. So we're going to divide both sides by 3. So we'll have 4 to the x equals 7/3. So if you just want to make a note here, that we must isolate the exponential term first. Must isolate exponential term first. Then, from here, we can see there's no way to write a 4 and a 7/3 with the same base, so we proceed to use our logarithms. So we have the two methods. We can use the direct definition of a log, or we can take log of both sides. So if we take log of both sides, remember we can take log, natural log, or common log, because either of those can be evaluated in the calculator. So I'll do natural log here, just for an example. So we'll have natural log of 4 to the x equals natural log of 7/3. And remember, this is useful because now this exponent can be multiplied out in the front, and then that we can solve for that variable. So we have x natural log 4 equals natural log 7/3. And then all we need to do is divide both sides by natural log 4, and we get x equals natural log 7/3 over natural log of 4. Now, if you notice, we've got a little fraction and a larger fraction, so we can actually rewrite. Remember, the log of a quotient, so natural log 7/3, can be split into two logs with subtraction. So to make this look simpler, we'll write this as natural log 7 minus natural log of 3 over natural log of 4. So just pay attention to how my math lab will accept it. I would assume they would accept either of these, but just experiment with that. And then this would be our exact answer, and then we can approximate in the calculator. So we want natural log 7 minus natural log 3, and then we want that whole quantity. So I should have enclosed parentheses up over here to begin with. So I'll insert my parentheses. So I want that entire difference, natural log 7 minus natural log 3, that should all be enclosed in parentheses. And then I'll divide by natural log 4. And so we can see it's approximately 0.611. Just pay attention to how many decimal places you're asked to round. So this is approximately 0.611. Now, if we wanted to, so this is the method of taking log of both sides. Or we could use the definition of a logarithm to solve this equation. So once we get to the 4 to the x equals 7/3, once we got to here, once we divided both sides by that 3, now we could just write this in the equivalent form using logarithms. So remember, the base of the log is the base of the exponent. So I want log base 4 of 7/3, and that's going to equal my variable, which is the exponent, which is the variable. So right here, we've isolated x. So we could write this, the log base 4 of 7/3. We can rewrite this as log of 7/3, or natural log here. We'll use natural log since that's what we used over here. natural log 7/3 over natural log 4, because if we want to evaluate in our calculator, we can't evaluate a base 4. And again, if we want to write this without the fraction in a fraction, we can split this log of the quotient 7/3 into the difference of natural log 7 and natural log 3. And we can see that, once again, we got the same answer that we got over here. So both of these are correct. But the most important thing to remember from this type of equation is when there's a constant being multiplied by that base, remember it's not 3 times 4 is 12, that exponent only applies to the 4, so we've got to remove that 3 before we can proceed to use logs and solve.